inside the center of the universe, if it exists at all. So here you can see a little bit more detailed how that redshift and blue shift works. And based on that research, Edwin Hubble, he stated that our universe keeps constantly expanding in all directions. And that's where the Big Bang Theory came from in the first place. And since we started talking about space, there's one real useful thing you can apply to satellites. So when the satellite orbits the Earth, it has the real huge Doppler shift in the frequency, and it has to communicate with the ground stations. So ground station is being stable relative to the satellite, but it constantly moves, and it moves in not the straight line, but the curvy, round or elliptical orbit. So that's why you have to apply Doppler's equations to compensate the shift in the frequencies, which can reach up to dozens of kilohertz, and because of that, satellite can lose communication completely. So Doppler effect also allows us not to lose the communication with the satellites. Here you can see much more detailed. So when it moves here, the frequency occurs to be more high, and when it moves past the ground station, the frequency drops down. Also not going to explain this, but whoever knows a bit of calculus would understand that pretty good. I'm only the first year student, so I just gave the pick. So, and the inspiring part, hooray, finally. So, getting back again to that picture, we have the Doppler equations for, the first one is for the case when the object moves towards you. So you stand here, and here the increased sound pitch of a car. And the second equation stands for this position of an observer, so you hear the lower pitch. And when I saw these equations, I actually realized that if you divide them by each other, you can get a sound interval between the sound of object moving towards you and past you. For example, a car. Once again, as I mentioned, it goes like so. They have a certain sound interval between them, and in music, sound intervals are being distinguished by ear by musicians. So if you divide those frequencies one by another, you get the representation of that interval, which is a constant number, by the way, no matter how much you move it around, higher or lower. So this F here, the frequency of the object itself, it just extinguishes. And there we, after a little bit tweaking in those equations, we have this. So this represents speed depending on the interval and the speed of sound, which is like 331 meters per second. And based on that, we can get the musical intervals of the cars when they move past you. So to give you a little bit more of understanding about musical intervals, for example, this one, perfect fourth, you all know that it's the first interval of the Russian national anthem. It goes like so like perfect fourth is but you just put it upside down, and when a car moves like Russian anthem, it's approximately 175 kilometers per hour. So I've done this fun research when I was still in school, and this is the final drop, I guess. Yeah, we anyway cannot hear the cars. I guess that can be the final drop to inspire you guys, since we're all engineers here. So even if the physical law is old as world, I mean, Doppler effect is almost 200 years old, you can still find more and more applications of it, and if you just use your brain properly, you can achieve a lot more. There are more laws. There's relativity theory, there's quantum physics. There's also this new fancy string theory. You can squeeze a lot out of those things and do a lot of awesome inventions, I guess. Okay, thank you. That's you know.
Thank you so much. I can only comment. It was a profound work. Just quite deep, extremely deep, I would say, just. But I'm too stupid to ask any questions about this aspect, guys. Probably you. Do we have engineers, mathematicians? Yeah, very hidden. Okay, Kirill, just thank you for your coming. Thank you so much, because I can't ask just anything about this. But if I could, I would. But that was brilliant, extremely. Just
Thank you.
no comments. Thank you so much. Just keep.
Can you guys do it real loud?
No. You?
No.
Yeah, go. Okay, and music pause.
Okay.
Here it is.
Really? Okay, and music will close and then we continue. Just a second.
Здесь есть Юлия Борисовна?